This is problem number 13 from section 3.3. In this problem it says, find the first and second derivatives, and they give you y equals 3x cubed plus 9 all over x. So you can see we're going to use the quotient rule to solve this problem. We're going to start by using the quotient rule to take the first derivative, so dy over dx is going to equal, and I'm going to write out here u prime, v prime, and this is the u function, and this is the v function. So I end up with u is 3x cubed plus 9, v is x. Derivative of 3x cubed plus 9, that's going to be 9 when you bring the 3 to the front, 3 times 3, x squared, subtract 1 from the power, and derivative of 9, that's 0. Derivative of x is 1. So dy over dx, using the quotient rule, is going to be 9x squared when we use u prime to start, times v, which is just x, minus v prime, which is 1, times u, which is 3x cubed plus 9, all over v squared, which is just going to be x squared. Let's do some simplifying here. This is 9x cubed minus, when I distribute this, technically I'm distributing a negative 1, so that's minus 3x cubed minus 9 all over x squared. So I end up with, that'd be 6x cubed minus 9 over x squared. So this is the first derivative for the function. So the second derivative that we're going to get here, so let's do d squared y over dx. Well, two things can happen here when we go to do this second derivative. We could use the quotient rule a second time if we wanted to. Or we could split this denominator between each of these and find this derivative without the quotient rule. And actually we could have done that at the beginning as well, which might have been, could have been a little easier. Let's go ahead and use the quotient rule again though. We need some practice. So we're going to use the quotient rule, and I'll actually show you the second part as well. We're going to use u being 6x cubed minus 9, u prime, v prime. So v is x squared. Derivative of this is 2x. Derivative of this function is 3 comes to the front. We end up with 18 x squared. That cancels. So now we can go ahead and write this as u prime, which is 18x squared, times v, which is x squared. And then we can write this as minus v prime, which is 2x, times u, which is 6x cubed minus 9. And that's all over v squared, which will be x squared squared. So we end up with, when we distribute here, 18x to the fourth. Distribute this 2x, we get minus 12x to the fourth plus 18x, just 18x, all over x to the fourth. Let's simplify some stuff here. That's 6x to the fourth plus 18x all over x to the fourth. Let's factor out an x here, so we end up with x 6x cubed plus 18 all over x to the fourth. Cancel the x and we end up with 6x cubed plus 18 over x cubed. And we could leave this here, or we could write this as, if we split the denominator, we get 6x cubed over x cubed plus 18 over x cubed. So you could write it as 6 plus 18 over x cubed if you wanted. So I think they'll probably accept this version or this version in my math lab, and both are okay. Now I do want to point out that we could have, at this very beginning portion, instead of using the quotient rule, what if we would have divided the x between each, so we have y equals 3x cubed over x plus 9 over x, which would give us 3x squared plus 9x to the negative 1 when we bring the x up. And now we could just use the power rule, and we would get 6x minus 9x to the negative 2. I hope you see where this is going. So then you end up with, 6x minus 9 over x squared, which is the exact same thing that we have right here. Find a common denominator, combine those, we have the same thing. So we could have used this version to find the derivative instead of using the quotient rule, and I just wanted to point that out.